see. Test, test. In the back, you can hear me? Raise your hand if, yeah, okay, or thumbs up. Well, thumb sideways means, I don't know, different thing.
Okay, so welcome back, everyone. I hope you had a great lunch, and everyone on Pine who's comfy on their couches, I hope you had also great lunch. Okay, we're digging in with our next speaker. This is Richard Gross, and Richard is IT architect at Myborn Wolf. If I'm pronouncing that correctly. Richard is a software archaeologist, Wi-Fi cable reseller, and software narwhal. After 10 years in the business, he's almost no longer a junior and about to become a teenager developer. He enjoys mastering TDD, BDD, DDD, decoupled design, and even practices that don't include two Ds. Richard, let's begin. This is From the Trenches, remote scale trunk-based development.
Great. Thanks for the introduction. I put all of that down there just so I could put nice symbols. If you ever wonder, Myborn Wolf does tailored software for people, by people who actually care. So we don't do product development, but we come in and develop software. Now, let's go for, oh right, and if you ever want the slides, the link is down there. If we are now talking about remote scale trunk-based development, I really hope I did not forget any buzzwords. I'm sure I could have put more in there. I didn't put microservices, I didn't put Kafka in there. Yeah, but you know, all of these words I actually did put in there are important to this talk. Now, let's start with the biggie, the question, the big one, which is, why do big software projects fail? Any ideas? Lack of financing. Oh, yeah, that's a good one. Scope creep. Yes, could be. Third one. Growing complexity, that's good. There's actually research about this. And of course, McKinsey does also research, and they say on average, large IT projects run 45% over budget and 7% over time, delivering 56% less value than predicted. Harvard Business Review are also doing some research on this, and they say 1 in 6 projects we studied was a black swan, meaning it had a huge cost overrun. Right? So instead of paying $10, well, developer money, they paid $20, $30, or $40. Right? So 4 times the cost, or even sometimes even more. If you're interested, the links are down in the bottom. And of course, there's the chaos report. It's been there since, I don't know, 1988, 89, maybe. And in the 2015 edition, they said that size of a project is the single most important factor in the outcome. The chaos report, if you haven't seen this, they categorize project into 3 categories. They say they're either successful, challenged, or failed. Successful is on time, on budget, and in scope. Challenged is, well, you delivered, but you know, you ran out of time or you ran out of scope. And failed is you did neither. Of course, with figures like this, I mean, look at this. 43% of grand projects failed. 51% were challenged and 6% were successful. There's always a point where you have to ask yourself, do big projects fail because they are big? Well, the figures lead to this conclusion. But at the same time, how many software projects fail at your company? I mean, based on these numbers, it must be like 70%, right? I'm assuming it isn't 70%. And that's kind of the criticism. Because if the research is right, it must be 50 to 70%, which is a good blog post down there. And it's probably not. I mean, if it is, please tell me after the talk or in the comment section. But this sort of leads to the whole point that the chaos report is really highly controversial. People are very critical of it. They say the definitions are solely based on estimation accuracy of cost, time, and functionality. Meaning, at the point where you start your project, where you have the least amount of knowledge, you need to be the most precise. You need to be very, very, very smart. And actually, I mean, that's impossible. The bigger the project, the less likely that is, right? They also say, the IEEE in this case, that the standard definitions have 4 major problems. They are misleading, one-sided, pervert the estimation factors, and result in meaningless figures. Why? If you govern your whole project just based on how good you are at estimating, well, it will lead to very, very useless estimates. Because either they are super large or everyone just ignores them. And independent study results are much more positive. And, well, the chaos report said, yes, sure, that's some valid points. Let's redefine how we define success. Let's change it to the modern definition, which is on time, on budget, with a satisfactory result. Meaning, if you start your project and you say, I'm going to do this, and after 2 months you realize, oh, actually for the user it's much more important to do that, then you can still be successful, which wasn't possible before 2015. Now, okay, so that's the research. But the interesting part about this, even if it's controversial, the thing the chaos report suggests, that's actually quite smart. And they say this. They say, think big, act small. What do they mean by this? Well, if your figures look like this, small projects, 76% likely to succeed, large projects, 10%, based on the Chaos Manifesto, by the way, link down there. Then how about you take your big project and you limit the size and complexity? Because that trumps all other factors. They say it doesn't matter what you do, as long as you make it small, that's much, much, much more likely to succeed. So break down large project into a sequence of smaller projects prioritized on direct business value. AKA, scale down the work. And then the Chaos Manifesto also says, these are the success factors for small projects. And the top one is executive management support by 20 points. Quite higher than user involvement, which is what, Agile preaches. And then, optimize and skill resources. People should actually be smart if you do a project. It helps. Now, okay, controversial, interesting results, but what do actual Agile experts think why big software projects fail? Politics. So, this goes back to what the Chaos Manifesto said, executive management support. So if you start a project and no one in the company wants it, well, that's going to fail. Good. Now that I've actually spent a lot of time saying why you should never, ever, ever do a large project, let's talk about what you do if you actually have a large project, or for some measure of large. I'm not going to talk about 200 people projects here. So a couple of years ago, my team, I was part of a bigger team, and a customer came to us, and this was pre-pandemic, by the way, as usual down there, and he said, I need 4 teams. Oh boy. Why did he do this? Well, I think it's because of some very, very simple, human nature. Complexity is sexy. I need 4 teams. I cannot do this with 2 or 1. I need 4 or better 20, right? I mean, that's kind of cool. And in some companies, the more people you have, the more power you have. I mean, obviously that's not true, but you know, that's kind of corporate politics. And in some ways, this complexity, this I need 4 teams, is also easier. Because you don't have to do the work to break it down before starting the project. You just, you have this huge scope, I don't know how it actually works, I need 4 teams. So, what's the theory now? The customer wants 4 teams. He really, really, really wants 4 teams. How can we make this work? Well, when we scale software, when we say, okay, I kind of want to start from small, when we scale software, we have a very simple process. We call it evolutionary design. Again, down there, industrial logic presents this concept. And it is, you build something very small with a very, very minimal feature set. In this case, a 2-string guitar. You recognize it's a guitar. You know, it doesn't sound great or anything, but it has 2 strings. It sort of does what a guitar does. It makes music. Not great, but it does it. And then you add to that. You add more strings. You make it a bit more complex. You make it, I don't know, possible to tune the guitar. You can still recognize the guitar. This might be enough. This might be okay. You could stop now. But probably someone's going to be like, oh, I definitely need all these features, so you build the even more complex guitar. I mean, this is definitely a guitar, right? I mean, it looks like any guitar you've probably seen. It's pretty good. It satisfies most people. It might actually already satisfy, let's say, 95% of your users. Maybe you should really, really stop now. Or maybe, you know, someone says, no, I definitely need to continue, so you build this one. And it's cooler, it has much more features, it can do all these fancy stuff, you can auto-tune it, whatever, I don't know, I'm not a guitarist. But at the same time, you've probably also lost users. Because the features that you added for the final 5%, they now made your app or software or whatever so complex that it's no longer that accessible. Think of your favorite mobile app. You downloaded it, it had like, I don't know, 2 buttons. It did exactly what you wanted. And then over the years, you know, buttons, they add a burger menu because they don't know where to put the buttons and everything, and now you have no longer the idea where you find the stuff you actually liked using. And you're like, okay, I'm gonna use a simpler app. It happens in software as well, right? I mean, you think of your favorite library framework, whatever. In the beginning it was like, oh, it's super easy to use. And then later on I'm like, no, I'm going to use something that is much more simple, much less opinionated, or the other way around. It's always the same, you know, it's a certain cycle. Now, that's how we scale software. We can scale teams in a very similar way. We scale teams by starting small. We let the teams talk about all these nice topics. Should we use hexagonal architecture, C#, F#, tab, spaces, whatever. Talking about what is good design, or saying, oh, I don't like how you use tests or how you write tests and everything. And you know, you have all these different connections in this small team. And you know, there's sort of always like this bit of conflict. But it's quite limited. It's not 20 people arguing, it's, well, in this case it's 6, maybe it's 4 in your case. Why? Because fresh teams have a lot of beef. I mean, assuming you haven't been working on the same project before. But they also have a lot to discover, because people come from different backgrounds. People have made different experiences, and that's awesome. And maybe the way you worked wasn't perfect. And maybe this guy over there, or that girl over there, they can tell you, hey, maybe in this case you should do this and that. And then you realize, oh, wow, that's great. That's awesome. I can do it this way. And yes, of course, in the end you agree. And it's much, much faster if you have a small team doing this. So, I suggest you scale teams via evolutionary division. You start in spring with a 1 American pizza team. American pizzas are large. 6 people. Then in summer you scale to 2 American pizzas. You can see there's some well, I don't want to say white people, but sorry. That's kind of the default color, it's white, yeah. Yeah, I'm not going into that anymore. And then at some point you realize, well, this team is too big, I'm gonna split it into two. So in autumn you have 3 American pizza team. Why? Well, you know, this one pizza is shared between 2 teams now. And in winter, maybe you already have 4 American pizzas. You are 20 developers. So you start small and you add to that and you divide as needed. Good. So, what did we do? Well, in spring, we started with 1 American pizza team. Specifically, because this one was pre-pandemic, we tried 1 co-located team. And I want to be very, very clear about this one. These are experiments. We tried it. We figured out if it worked. For that to actually work, well, we also adopted a process to improve. We tried. Personally, maybe I should have not put try there, but do, because if you don't have a process to improve, you will actually get stale and, you know, digress and everything. But anyway, try, adopt a process to improve. For us, the core meeting was, funnily enough, the dev talk. It's 1 hour, it's weekly. We present, discuss and agree on technology. The things we discuss about, we actually put them in architecture decision records, short ADRs. And in the beginning, you write a lot of ADRs. The important point is, in an architecture decision record, you write down why you made this decision. And the next person who comes new into the team, he can now read this ADR. Because that's the beef, right? It's whenever you come into a new project, you're like, okay, why are you doing this way? This is stupid. Well, there's a document, it explains why you made this decision. And the person who comes in later now, well, that person can not only look at the document, but well, she can say, hey, you made this decision, I don't know, 3 months ago, but the parameters have changed. Maybe you should rethink this decision. So don't rethink a decision if nothing has changed, because, well, why would you do that? But if things have changed, I don't know, technology hasn't got better, something has gotten slower, I don't know, well, how about you rethink ADRs? Of course, from a dev talk, usually also an artifact of that are, well, I want to change the code base. Well, when do you do that? If you're lucky, you can do it as part of a feature, but often enough, decisions that are made are sometimes like they're kind of broad-reaching. They're not specific to a feature. They're like cover your whole code base. So you need slack time. You need specifically dedicated slack time each sprint. So don't stuff your sprint with 100% features, but put slack time in there. For us, only for us, it was awesome to have one full day of slack time per week. Sounds like a lot, but think of all the work you're doing that's not feature related, and this usually comes to 1 day. Of course, you also have the retro. While the dev talk is very technology focused, the retro is process based. What do you keep? What do you try? And well, the results you often put to a team charter for the same reason that you put that you create ADRs. You want to have a single document that explains all the things you agreed on. Well, not all, but like the important ones. And back and forth. Because the retro is 2 hours, bi-weekly, which I mean to say every 2 weeks. Not twice per week, which apparently is also another interpretation of bi-weekly. So, I've already said Scrum, so yes, we tried adopting and adapting Scrum. In brown, you can see the original Scrum events. In green, you can see what we added. You can also see that there's a dedicated refinement. We put there, 30 minutes, twice per week for the whole team. Why? Because, well, according to a Scrum guide, refinement is something you do, not an event, so we made an event out of it. I'm not saying this is the perfect thing for everyone, but that's what usually happens. We also took something from BDD, which is the 3 Amigo meeting, which is a tester, a developer, and a business analyst talk about a story before it's presented in the actual refinement. Why? Because it's a bit more efficient to only talk about with 3 people and figure out the rough kinks before you talk in the large group. Dev talk and Slack time I already told you about. So, try explicit Slack time. You need time to do retro and tag items. And at least in my experience, my product owner is super happy if he never, ever sees a tag, task, enabler, something in the backlog. Because he doesn't know how to prioritize it. He's like, oh, I don't know if this is more important than my feature. So if your Slack time can help him to only have a business-focused backlog, he will be super happy. Right. Down there I said number 2, given devs 2 days of Slack time each sprint. Why? Because it's a small price to pay when it stabilizes estimation and planning. If your velocity is constant or like slightly increasing every sprint, great, I can estimate into the future. If it's like this, well, future is very uncertain. And yeah, in the end, I mean, the backlog is supposed to be only about business features, so great, let's keep them out there. Of course, this is talk about trunk-based development, so yeah, of course, we tried trunk-based development. And I really think it's the simplest, nicest branching model. And the DORA, the DevOps Research something, they actually have research about this. They say it's predictive of success. Doesn't mean you're successful automatically, but if you do trunk-based development, you're more likely to succeed than not. What does trunk-based development mean? Well, you have one branch, you call it trunk, you call it main, you call it master, whatever, and every work happens on that, and you integrate multiple times per day. Because if you don't do that, well, you get this, long-lived feature branches, where you make a commit, and you make a commit on main, and everything is great, and then you branch off, and you sort of see this divergence, and then another person branches off, and you see that they're even more like going away from main. So it's not linearly, it's exponential, because everyone is sort of working in parallel on different branches, and every commit creates this exponential change, and this divergence that only goes worse and worse the longer the time stays. So keep in mind I'm saying long-lived feature branches. If you do a feature branch and you merge it back in within 4 hours, whatever. But if it's like 2 days, could be a lot of stuff that happens. Could go like this, it could diverge even more. And then at one point you try to merge it back, and it usually explodes, specifically in Scrum, where you have a sprint. And at the end of the sprint, everyone just very quickly tries to bring back the branches, and you realize, oh, if I'm first, I don't have to do the merge hell, someone else has the problem. Right? So the first person to merge wins, and then he can just go home, and everyone is like busy 6 hours just trying to resolve merge conflicts. Of course, this grows worse the longer your feature branch goes on, which is why I'm also super against refactoring branches. These are the worst. Specifically, if you just rename something, that's horrible. In the end, avoid continuous isolation. Don't do branches. They only increase your personal productivity. They discourage refactoring. Of course, they increase the batch size the longer the branch goes on, and they increase the risk. What risk? Well, the risk of integration. Continuous integration, on the other hand, means daily merges. Right? You integrate your work with your fellow colleagues, and you can already profit from their refactorings. You can already use what changes, what cool features they've put in there, this cool new library function. And because you're integrating daily, well, you're also decreasing batch size and of course risk, because you already know your feature works with everyone else's features. As I talk about this, of course, as usual, it's called Feature Branches Are Evil, and a couple of blog posts down there in the corner. If you do this, however, you should definitely, for sure, I mean, this is a standard practice, but still, it's worth repeating, pair trunk-based development with a maintained pipeline. What do I mean by maintained? Well, when the pipeline says something, you actually try to fix it instead of just ignoring it. How does it look like in practice? Well, you do a couple of commits and then pushes. So I do 2 refactoring, that's lowercase r, stands for refactoring, it's low risk because I'm refactoring. 2 commits and then push, and my pipeline runs and it's green. Why is it green? Well, it does all these nice things. It does linting, it does unit testing, it does integration testing, maybe it even does nice post-deploy smoke tests and post-deploy monitoring. All of these are awesome. And then you do some more refactoring because you realize to implement this feature, I should probably do a couple of refactoring. I want to have this feature here so I can do my refactoring before. Preparatory refactoring, I think Martin Fowler calls it. And all of these are very small and focused commits. So they're also nice to see, and you're like, oh, okay, why did you do this change? I mean, you know this, if you change a core function, if you change the name of that, and its core function is used by everyone else, well, suddenly 200 files are changed. That's a huge commit. But if your commit message now says rename function to that, and you push it like this, well, then the next commit that you make that is much more important, you can easily see the difference. You know this one is about refactoring this method, 260 files changed, I don't care, it's just refactoring this one method, and then you have this important commit. And of course, at some point you make a large case F, as in behavior changing commit, a feature commit, pipeline stays green, great, you've implemented part of the feature. You continue, you forgot something, I don't know. Forgot to add a file, happens. Your refactoring, I don't know, for some reason didn't work. Pipeline's red, what do you do? Well, you're like, okay, can I fix this within 10 minutes? Why 10 minutes? Well, because everyone is depending on the pipeline to be green, because otherwise, if the pipeline is red, they're not allowed to push. So you figure out, okay, can I do this? Can I fix this in 10 minutes? If not, it is revert. It's a small focus commit, so if I revert, whatever, doesn't hurt me. And specifically, I know which commit to revert because it's small and focused. It's green again. Yeah, within 10 minutes. I improve the commit to actually make it work, and then the pipeline is green. What does it mean? Well, main or trunk or whatever is always in a releasable state. If you're interested in the commit notation I use, it's Arlo's commit notation. It's down there in the right corner. Here's a nice GitHub link for that. Good. So that was Spring. Then our customer approaches again. And he says, he not only says, I want 4 teams, he says, I want scalable software. Great, woo. So that starts us into summer. We are now at 2 pizza teams. And specifically, we did this already in spring, but for context, it's kind of put here. We started with monolith. Why? Because at project inception, of course, you have the least knowledge. You don't know where your software is going. Modeling can and will change a lot in the beginning. And if you have a monolith, you actually can use refactoring tools. You can use this move function and it moves it over there. You cannot do that if you have multiple services. Well, you can, but you know there's no tool support for it. Of course, there's a trade-off as usual. Everything's about trade-offs. Splitting about monolith is not a freebie either. We, in the end, when the customer said, hey, we want scalable software, we split up the monolith with event-driven communication. Like this, it became one monolith, became multiple services. They all communicated, in our case, via Kafka. They pushed messages there, they received messages, and so on and so on. It works really, really nicely. It has nothing to do with trunk-based development, remote or scaled, but it's just an awesome way to split up and integrate services. But again, it was not a freebie. We split up the monolith. It took us, I don't know, 2 to 4 weeks to actually have this running. Because suddenly things that were synchronous and blocking now suddenly became asynchronous, and for some reason that kind of creates problems. We also tried keeping everything in one repo. All the services, all the shared libraries, all the documentation. Onboarding shell script. Awesome thing. It's a shell script that you launch when you come new to the project, and the shell script tells you what you have installed, what you haven't installed, and what you can do to fix it. It's like a README on steroids. But in the end, it's everything your team needs. And because you put your shared libraries in there, while everyone just depends on the source code of the shared library, so if you do a refactoring of the shared library, every service that uses the shared library also changes at the same time. So you don't really do library versioning, which is nice. In the end, you see everything everywhere all at once. Too few people have seen that movie. Okay. Of course, you filter what you need right now. Your refactoring tools help you with every change, and well, in our case, we could unit test all services in memory. We had an abstraction in there for Kafka. We just put our in-memory event bus in there. Simple thing to write, actually. And well, we could unit test all services. It was super fast. We were like, I don't know, 1 minute, and then we knew all services work. Of course, our customer again approaches, still pre-pandemic. He not only wants 4 teams, but in scalable software also wants more in parallel. So there we go, autumn. 3 pizza teams. 2, I think we called them streams at that point. We had one, all developers together, the team, and well, the 2 bubbles we call streams. Specifically, we tried dynamic, I should have written dynamic feature streams, but well. We tried dynamic feature streams. What does it mean? In the planning, we present all the topics in the backlog, topic A, and we present what backlog items are for which topic. And then everyone, pre-pandemic, not remote, everyone took their post-it with a name, and then in planning 1.5, everyone had their post-it and put it on the topic they would like to work on. And, well, in the end, you now have dynamic teams. Because every 2 weeks they could change. And that means you still have a lot of division of knowledge. A lot of shared knowledge. Because everyone is usually, because every 2 weeks he or she could work in a different part of the code base, she still knows what's going on. She still understands the whole code base because, well, you're switching. An even more extreme version of this is down there, fast agile. They do this potential feature reteaming every 2 days. I mean, our process, sometimes we kept the same team dynamic, same stream members over multiple sprints. It's the same for fast, but potentially you could switch all 2 days. Right, every team member can work anywhere in repo. Again, it's just for knowledge sharing and for collaborate code ownership. And in the end, we aligned via the coffee machine. Pre-pandemic, you met there and one person is like, hey, I'm working on this part. And you're like, hey, cool, wait, before you work on that part, I have a library I'm working on. You can use it. You align via the dev talk and ADRs, of course, every week. And you align via team reteaming. Because, of course, if you worked on something that now the new stream needs to use and you're in that stream, you can just tell them, hey, look, you can use this. As it is, our customer approaches again. He also wants more speed. And he really hates remote because now we're in the pandemic. So, that brings us into winter. 5 teams. 1 team, 5 streams. So the The customer says more speed. Well, how do you get more speed? By increasing efficiency. It's a iffy trade-off, right? I mean, maybe you increase efficiency so much you become less effective. But in our case, we had some ideas what we could do. Specifically, reducing meetings. Yeah, okay, you've done this, okay. In our case, for the daily, for example, we said, okay, not the whole team has to be there, because 20 people potentially talking is quite a lot. For the 3 amigos, we said we don't need that. For the refinement, we said we don't no longer going to do that in the team. And for the planning, we generally said we're not going to need that. We are going to replace it with some other things, but that's the gist of it. The other thing we did was we said we no longer want to do dynamic feature streams. We want to do stable streams. We did an inception where everyone took their post-it and put it semi-permanently with the stream they wanted to work with. Why could we do this? Well, everyone had sort of worked together with everyone. Everyone knew who they can work with, or who they, couldn't work with very, very badly. And we could do this because, well, we had tried dynamic feature streams before that. Why did we do that? Well, we said the problem with dynamic feature streams is you sort of go into the storming phase every new sprint. Because yes, you have worked with them, but it's always like, I really want to do this. I don't like the way you do it. So you have a bit of this beef every 2 weeks. If you go for the stability, that changes. You have much longer time to come accustomed to each other. Even the nuts and bolts that usually just gloss over because you're only going to work together with them for 2 weeks. We also tried one shared backlog. We said, well, okay, we are one team, 5 streams, we have one shared backlog with backlog items. How do we now assign the work? Well, we said something like, we call it the stable what's next. Because each of these backlog items, they have, well, in this case, a different color, but that just means they are for a different stream. And our business analysts, they divided up the features based on what stream is supposed to do that. It's only 3 here, and should be 5 because we were 5. And we had a weekly what's next meeting for each stream. And maybe you can now see why we call them streams, because there's a feature stream, so every stream worked on that. It was stream A to E. But in your case, it could be, I don't know, stream green, blue, red, whatever. Right, this what's next just presented what's in the backlog. It didn't do anything according to commitment, and everything was just, hey, this is next. And we could still plan the future because we now, by this point, had very stable velocity, so we knew, okay, well, you're going to do this many points in this many weeks, so in 3 months, we are probably going to be done by that. And now each stream can individually do their task breakdown. We also tried something called flexible cadences. You can see it here. Instead of having this 2-week heartbeat that Scrum does, and Scrum does it well, we did flexible cadences. We said, well, the daily is daily, but we now have a 20-minute stream retro at the end of the day. Why? Well, because some issues are very, very fresh in your mind at the end of the day, but they are not that fresh 2 weeks later. And sometimes we just hung out. I mean, and this was, again, pandemic now. So it was just also a place to come together again and in the stream and talk. And actually retro by this point was very, very fast because you were very focused on, hey, this annoys me. I would like to change it to that. And then you talk to this, and usually there were only one topic per day. And then you see if you can do it better the next day. It's very, very fast, very, very fluid. The refinement, 30 minutes only, 3 per week, 3 people, so meaning 1 out of the 4 people in the stream can still continue the work while the other 3 refined. And because it was only three people, well, we just said, okay, we don't need the 3 amigos. We increased the dev talk slightly because we were that many people and it was hard to keep track of time. We had the what's next. 1 hour was the reserve time, but usually it was more like 30 minutes. Of course, we needed to align every 2 months to see where the roadmap was going and how each feature is situated in the story map. That's just for context, so I know I'm working on this and the other stream is working on that. And then we had on-demand retros. Right? If you had a bigger topic and you couldn't discuss it at the end of the day, it was 20 minutes. Or if you wanted to have a whole team retro, it was on demand. We definitely tried response team, meaning one of the 5 streams was only responsible for responding to, well, unplanned stuff. They kept production stable, they kept the dev environment, the pipeline, the whatever Kubernetes cluster stable, so everyone else could focus on their features. Right? You never had a situation where there's a production bug and then no one felt responsible. Or there's a production bug, someone feels responsible, but well, she's working on the most important feature and she can't switch. You always had this response team, and they not only kept that stuff, based on their experience, they said, well, proactively, I'm going to work on this thing to keep even more stability. And yes, in that order. And yeah, it was the one special team. The other ones were focused on features. This one was focused on, well, just responding. In Nexus, you would call it, I think, an integration team. We also had a very simple method for figuring out which person or which people I can talk to. Because that's kind of the issue, right? You're working remotely. How do you find people that can help you with the problem? Normally you walk into a room and you see people sitting at a desk and you know this person who's sitting like this, you shouldn't bother him. While the other person might even chat you up and you can talk about your problem. Well, we said in a remote meeting, we use Microsoft Teams, so it became like this. We had team internal, so no one from the outside world. Team internal channels or calendar events. And Teams does this fun thing where you can see if someone is there. There's no symbol here, so no one is there, or everyone decided to go into focus mode, meaning I don't want to be disturbed right now. While if the camera symbol shows up, I know, okay, someone is there working on a feature. Meaning the business analyst can go there and ask questions, or other developers can go there. And of course, same is for the Discovery channel where the business analysts hang out, where you can also go and ask questions, because the longer delay you have, the more expensive it is. So if you can resolve something very fast, like hey, I don't know how to implement this feature exactly at this point because it's not specified, the faster you get. Summary. We went from one team with 6 developers to one team consisting of 5 streams with, that's supposed to be 20, not football score. We went from 2 weeks sprint to continuous. Went from 2 hours planning to 1 hour what's next meeting. From dev talk decisions to stream decisions. But the presentation in dev talk, you could decide very fast what you want to do. Normally you also pick someone from any other stream just to have their input, and then you just present the decision in the dev talk. Went from whole team 2-hour retros every 2 weeks to daily 20-minute retros, and on-demand large stream team retros. In the end, we improved as a team. It wasn't forced upon us. We decided to make these changes. The customer said, well, I want to have more done in parallel, and we were like, okay, well, let's try this. So this is important. We improved as a team, as people. Why? Because people issues determine a project speed. Can the people easily detect something needs attention? Will they care enough to do something about it? And can they effectively pass along the information? all of these factors are improved by letting people make their own changes, right? So if you're like, hey, this is pretty cool, or you're like, this is pretty stupid, but anyway, I would suggest if you try this, you first make sure you have a process to experiment and improve. But you should also have the right mindset. Because you should definitely try remote-based, trunk-based development. Just don't forget it's not about the techniques. Well, building a cool pipeline is easy. But then you have the techniques, something like, I don't know, testing. You have the methods, which is when you do it, TDD. You do it all the time. But if you actually do it, that depends on your mindset. And that's super, super hard. It requires a lot of change, and that's why we have all these retros and dev talks and everything, because we are kind of change unwilling. If we make the changes ourselves, well, that's much, much better. Thank you.
Okay, thank you very much, Richard. Now, I am walking here with microphone for your questions, so this is your time. Who's raising the first hand and breaking the ice? There we go.
Yeah, thank you, Richard. That was an awesome presentation. I have a question around if you decided to have stable streams with stable people, but one of the teams always deals with operational issues and the fires, right? So did these people have like SRE experience? Did they like doing it? Do they ever get to rotate and do like feature work, or how does that work?
Okay, so it's about the response stream. So before we had a fixed response team or response stream, it was actually rotating. We had one large, so in spring and summer and autumn, it was 2 people who were rotating each 2 weeks, and there was always one person who was more experienced and stayed there and explained the concepts and things to watch for to the new person. So that's why when we went to the stable streams, we already had sort of this group that were more interested in that topic. And they said, oh, okay, cool, I want to stay in this response stream now for longer. But we never shut the door for like stream changes. It didn't happen, but we said, well, anytime you want to switch, well, we can do that. We just didn't have a regular cadence for it. It was more on demand. You know, that could be good or bad, because, you know, if you don't put room there, maybe some people are too shy to say it. But usually during retros, that I think would have come up. Did I answer your question?
Okay, there was another hand somewhere here. There we go.
Thank you. I have 2 questions. One based on the trunk-based development. So you never ever do feature branches, right?
I usually don't do feature branches. I do it for infrastructure changes. You know, when you kind of change the database or you change the GitLab pipeline and you don't want everyone to depend on this one line, you just don't know what the annotation is and you're like, damn it. So that's when I usually do feature branches. But yeah, for the most part, I don't do feature branches at all.
Okay, cool. And the second question is also about the response team. When the response team needs to fix all the production bugs, they also need to have very deep domain knowledge. Isn't it a problem sometime?
Wasn't for us because we had this dynamic reteaming before we went to the stable response streams, so everyone knew everything in the code base. But yes, as long as the longer the response stream continues, the less knowledge it had about this. So we always had this mechanism where the response stream could always say, hey, look, this bug, I don't know how to fix it, and you know, git blame or whatever, and you're like, okay, this person, please help me, right? You always had this option. Because, right, it's much more important to fix the bug and fix it well than to always stay in focus mode. The intent was to never let that happen, and usually it wasn't needed, because we had quite good test coverage, actually. But that was the option as well.
Okay, cool, thank you.
Okay, we only have 1 minute left, so last quick and short question, if there are any. Okay, I guess then round of applause.
Okay.
Brilliant. Okay, so thank you very much. We're gonna have a short 10-minute break and we'll continue.